All right, so here we go on your quiz 17 study guide. And problem number 1 asks you to, or it tells you in the rhombus, angle 1 equals, angle 2 equals, and angle 3 equals. Find the value of each variable. The diagram is not to scale. It is a rhombus. And in a rhombus, diagonals are perpendicular. So if the diagonals are perpendicular, aren't all of these angles 90 degrees? So 18x equals 90. Divide each side by 18. And your x equals 90 divided by 18 is? Good, 5. And then what we're going to do for angle 2. All right, let's see. Find the value of each variable. So there's our x. Our x is equal to 5. So for angle 2 here, we've got x plus y equals 90. So we're going to substitute this 5 right in here for the x. So we're going to do 5 plus y equals 90. And subtract 5 from each side. And our y is equal to 85. And then for z, angle 3, 30z is equal to 90. And divide each side by 30. So our z is equal to 3. Diagonals of a rhombus are perpendicular. Excuse me. In problem number 2, in the rhombus, angle 1 is 106 degrees. So I'm going to replace this with 106. What are the measures of angle 2 and the measure of angle 3? The diagram is not to scale. All right, so diagram or rhombus. These opposite angles are congruent. So this angle 2 down here is 106. So also in a rhombus, the diagonals bisect opposite angles. So that means that angle 3 here and this angle over here on the left, I'm going to change this to an x right now and this to an x. Because look what you have here, guys. Whether it's a rhombus or not, you've got an isosceles triangle down here on the bottom. And in an isosceles triangle, if you know the vertex angle, you can write an equation for the sum of the angles. So we've got 2x plus 106 that has to equal 180. So subtract 106 from each side. And 2x equals 74. Divide each side by 2. And our x, which in this case represents angle 3, is 74 divided by 2, which is good, 37. So the measure of angle 2 is equal to 106, and the measure of angle 3 is equal to 37. Problem number 3. Find the measure of the numbered angles in the rhombus. Diagram is not to scale. Well, we just said that the diagonals of a rhombus are perpendicular. So the measure of angle 1 is equal to 90 degrees. All right, so we also said that diagonals in a rhombus bisect opposite angles. So we've got this going on. So each of these smaller angles that my cursor is on are 41 degrees. So the measure of angle 2 is equal to 41 degrees. And now what we've got, if the measure of angle 2 is 41, then the measure of the angle next to it is also 41. So now we've got a right triangle here. One angle's 90, one angle's 41, and we need the measure of angle 3. So the measure of angle 3 is equal to 180 minus 90 minus 41. And 180 minus 90 minus 41 is 49 degrees. Problem number 4. DEFG is a rectangle. DF is 5x minus 5. All right, so D to F is a diagonal. And EG is another diagonal. All right, diagonals of a rectangle are congruent. We got a rectangle, so diagonals are congruent. Find the value of x and the length of each diagonal. All right, so 5x minus 5 is equal to x plus 11. Gonna subtract x from each side. And 4x minus 5 is equal to 11. And add 5 to each side. 4x is equal to 16. And then we can divide both sides by 4. So we get an x that's equal to 4. And that was the first part of the question. There's your value of x. And the length of each diagonal. So DF is equal to 5 times 4 minus 5. And that's 20 minus 5, which is 15. E to G is equal to 5 plus 11. Wait a minute here. Something doesn't look right. Oh, I'm sorry. X is equal to 4. So EG is equal to 4 plus 11, and 4 plus 11 is 15 as well. So there's your value of x and the length of each diagonal. All right, in problem number 5, quadrilateral ABCD, the measure of ACD is 2x plus 4. And the measure of ACB is 5x minus 11. For what value of x is ABCD a rhombus? All right, in a rhombus, diagonals bisect opposite angles. So we need a value of x that makes these two angles equal to each other. So we're going to take 2x plus 4 and make it equal to 5x minus 11. Subtract 2x from each side. And 4 is equal to 3x minus 11. Add 11 to each side. 15 equals 3x. And then you can divide both sides by 3. So 5 is equal to x. When x is equal to 5, these two angles are congruent. And when those two angles are congruent, then ABCD is a rhombus. In problem number 6, find the values of A and B. The diagram is not to scale. All right. In order to make this really simple, if you were to take this top line, you've got two parallel lines, and extend it. That makes these two lines are parallel and they're cut by a transversal. So aren't these two angles, the A and the 36, aren't they same side interior? And same side interior angles are supplementary. So A plus 36 equals 180. All right, we covered that a long time ago. It doesn't matter if this is a trapezoid or not. You still have two parallel lines cut by a transversal. So subtract 360 from each side, or 336, I'm sorry. So our A is equal to 180 minus 36, 144. The same thing holds true if we add another transversal or if we just extend this right side of the trapezoid. Two parallel lines cut by a transversal. We've got same side interior angles again. So 113 plus B is equal to 180. Subtract 113 from each side. And B is equal to 67. All right, and you can double check your answer if you like on the quiz. If this is 144 and this is 67, the four angles in a quadrilateral need to sum 360. So when you solve for A and B, just make sure that the four angles inside this trapezoid sum 360. Problem number 7, you're told J and M are base angles of isosceles trapezoid JKLM. So let's draw a trapezoid. Base angles. So the two parallel sides are bases. J and M. Here's J, here's M. The other two vertices are K and L. Isosceles trapezoid. These sides are congruent, which means these top angles are congruent and these bottom angles are also congruent. Another property of an isosceles trapezoid is that diagonals are congruent. But here's where we got the measure of angle J is 20x plus 9. So 20x plus 9. And the measure of angle M is 14x plus 15. 14x plus 15. You need to find the measure of angle K. And angle K is up here. So the first thing we're going to do is solve for x. We're going to take 20x plus 9 and set it equal to 14x plus 15. Going to subtract 14 from each side, subtract 14x from each side. So 6x plus 9 is equal to 15. Subtract 9 from each side. 6x is equal to 6. And then divide each side by 6. So what we get here is an x value that's equal to 1. With the x value that's equal to 1, we can find the measure of angle J. The measure of angle J is equal to 20 times 1 plus 9. And 20 times 1 plus 9 is 29. So this angle down here, angle J, is 29 degrees. Well, we just said that if we extend this top and extend this bottom, we've got a transversal that cuts two parallel lines. So angle K and angle J are supplementary. So the measure of angle K is equal to 180 minus 29. And 180 minus 29 is 151. All right, we got same side interior angles again. They are supplementary. Problem number 8, you are told that the isosceles trapezoid, that's the shape here on the bottom, isosceles trapezoid, is part of an isosceles triangle. That's the big triangle. With a 46-degree vertex angle. Vertex angle, that's this one up here. 46 degrees. What is the measure of an acute base angle of the trapezoid of an obtuse base angle? The diagram's not to scale. What you need is this angle, and you need this angle. And what we know from this isosceles trapezoid is that these two angles are congruent because these two sides are congruent because you're told it was an isosceles trapezoid. So what we do is label these base angles x, and we look at this big triangle first. All right, we've got a big triangle, an isosceles triangle around the outside here. That isosceles triangle around the outside, these three angles need to sum 180. So we get 2x again plus 46. That has to equal 180. Subtract 46 from each side. So our 2x is equal to 134. Divide each side by 2. and we get an x that's equal to 67. Now, what the x represents is one of the acute angles of the trapezoid. So the acute angle is equal to 67 degrees. It's less than 90. The obtuse angle, which is right above it here, right? Here's your acute angle. Here's your obtuse angle. This is like the third problem in a row that we've got same side interior angles, because we can extend this line and it's parallel to this line because you're told it's a trapezoid. So the left-hand side of this big triangle creates a transversal. So this obtuse angle, the obtuse angle, is equal to 180 minus 67. And 180 minus 67 is 113 degrees. All right, problem number 9. LM is a midsegment of ABCD. AB is 46. DC is 105. 125, I'm sorry. Thank you. What is LM? The length of the midsegment. We said yesterday that the length of the midsegment is equal to the average length of the bases. So LM is equal to 46 plus 125 divided by 2. And 46 plus 125, 171, divided by 2, 85.5. All right, problem number 10. LM is a midsegment again. AB is x plus 8. D to C is 201. What is the value of x? I'm sorry, I missed LM there. LM is 4x plus 3. What is the value of x? So the length of the midsegment, 4x plus 3, is equal to the average length of the bases. Well, the average length of the bases is going to be x plus 8 plus 201 divided by 2. So the first thing we're going to do is get this 2 out of the denominator, and we do that by multiplying both sides by 2. And make sure you use the distributive property on the left-hand side of this equation. We got 2 times 4x, which is 8x, and 2 times 3, which is 6. And that's equal to, on this right-hand side, we multiplied by 2, So these would cancel out. Our x falls down, plus 8 plus 21 is 209. So now we can solve for x. Gonna subtract x from each side. 7x plus 6 is equal to 209. Subtract 6 from each side. And 7x equals 203. Divide both sides by 7. And we get an x that's equal to 29. And that completes your study guide for quiz number 17.